systems as well as Mark Forged solutions. Jarod and I met about I guess it was a year ago at IMTS. Brought us a very unique solution need for conformal cooling, which he'll talk about in depth today. But just wanted to introduce myself real quickly, what we do. We're not a manufacturer of machine tools. We are a machine tool distributor. Been in the business for about 60 years on the machine cutting tool side. Brought additive into our portfolio a few years ago. And really our goal is to deliver turnkey solutions for customers, from machines all the way up through engineering and service and production cell development. So very pleased to have a customer here, much like Dr. Hyatt was earlier with DMG and Virgin Orbit. Much rather have a customer stand up and talk to you about what he's doing with additive in production, daily production. And hopefully you get a little bit of flavor of what B&J has been doing over the last year and what we bring to the industry. So please help me welcome Jarod.
Thank you. B&J has started out from a very small shop. It originally was an idea between a father and son. They had a dream of wanting to make something of themselves in a small town. It literally started in a garage, with nothing more than just a dream, and a vision of wanting to become something. So in a small town in northeastern Indiana, in America's heartland, is B&J Specialty Incorporated. First glance at the surroundings does not give new clients a clue that they're about to enter a world-class mold-making operation. But that is exactly what you'll find. Since 1975, B&J Specialty has been providing molds, dies, and build-to-print tooling services that meet and exceed our customers' expectations and requirements. You will find our commitment to customer service, along with our work ethic, and the ability to get the job done are among the highest in our industry. We take pride in our work, always looking, always wondering what could make us better, what could make us faster. What can we do that others haven't even thought of yet? How do we make sure our customers want to create a lasting relationship? Our CEO, John Wicker, will be one of the first ones to tell you. It starts with having the right tools for the job, along with having the people with the experience and the knowledge to capitalize on those investments. Our engineering and manufacturing abilities are top-notch. We have some of the best people in the business. Throughout the years, B&J has been evolving with the times, always advancing, as well as improving our methods and technology used for meeting our customers' needs. Whether it's high-speed machining, micro welding, CNC laser welding, reverse engineering, mold and die repair, or new builds, B&J Specialty continues to strive for excellence with the implementation of cutting-edge technology and advanced methods of manufacturing. I have had the honor of working for B&J for almost 20 years. I can tell you firsthand, if it wasn't for having an owner with an innovative way of thinking, B&J would not be where it is today. Our mindset has been based on the fact if you want to survive in today's competitive molding industry, you have to be willing to take risks. You need to ask questions, and you have to be open to change. We at B&J continue to step out of our comfort zone to try new things to help develop better techniques when designing and building our products. But inevitably, we often find ourselves at a crossroad, figuring out how we can have a component's design optimized for the function it'll serve while at the same time making it practical for the manufacturing process. In the plastics molding industry, most designs are completed and then cooling lines and circuits are the last thing to incorporate into the mold's design. Oftentimes, the mold designer will have the odds against them due to the lack of space needed to route an effective cooling line circuit. This results in inconsistent cooling, which as a consequence can lead to several failing conditions, such as part warping, bad sink marks, and long cycle times while molding, just to name a few. Cooling a mold effectively has always been limited due to the methods used for conventionally manufacturing the cooling line's passage. This is typically done by drilling intersecting holes throughout the geometry in an attempt to get water into the core and cavity blocks the best you can. This is the method the industry has been using for decades. It's not uncommon to have several required adjustments made to an injection mold when dealing with the limitations put upon you from the conventional ways of manufacturing. Several critical dimensions have to be achieved before a mold gets released for production. In the 1980s, Chuck Hull had a dilemma, and it too was associated with the molding industry. He saw the need to figure out how to rapidly produce prototype plastic parts for the use of design engineers. Chuck began to imagine how he could print three-dimensional parts. His concept idea was coming up with a way to build several two-dimensional layers on top of each other, creating a three-dimensional part. Through trial and error, in 1983, he successfully printed a small plastic cup, inventing what he called stereolithography, and it has set the foundation for 3D printing as we know it today. Back then, Chuck didn't realize his development of his newfound technology was about to change the world of manufacturing. Based upon using those same core principles, the technology has made astonishing advancements in the last 34 years. With the introduction of powder bed fusion technology, we can now 3D print metal parts. Developed specially for this type of printing is a powder form of material called miraging steel. This material has similar properties to the commonly used tool steels, making it ideal for the molding industry. With the use of direct metal printing technology, this highly dense, sintered material is able to be heat treated, machined, and also can be highly polished. Methods 3D enabled B&J Specialty to deploy a 3D Systems Pro X DMP300 3D printer into our facility to integrate 3D printing and conformal cooling technology into a single solution. Showing B&J our manufacturing limitations can be something of the past. I am now proud to say that B&J Specialty can achieve optimal cooling by supplying effective water into areas that would normally be impossible using conventional machining methods. Utilizing the direct metal printing, or also known as DMP technology, we not only can maintain a uniform distance between the molding surface and the cooling lines, but we can also alter the geometrical shape to adapt for any pressure drops throughout that line, while also having the power to manipulate the shape to get into tight areas of geometry while still maintaining the critical cross-section area of the cooling feature, making it an effective cooling circuit. This alone can dramatically shorten the cycle time of each molded part and also reduce the amount of part defects due to inadequate cooling. An injection mold's cycle typically has 5 stages throughout the process. The cooling stage The injection mold cycle typically has 5 stages throughout the process. The cooling stage of the cycle can be over 50% of the overall cycle time. This is why having proper cooling is such a vital key. I am not able to show you the case study results because of confidentiality agreements, but I can tell you we achieved massive improvements in cooling properties when implementing conformal cooling technology into our designs. The virtual molding analysis results showed a standard design when using conventional methods of manufacturing had over a 132-degree deviation in temperature across the geometry. Having such a variance in temperature can be catastrophic when molding a plastic part. The same core block design, but now with conformal cooling passages implemented into the design, was then tested. An astonishing thing happened. Analysis results proved that properly placed and designed conformal passages can dramatically improve a mold's cooling properties. The analytical results now show that there only was an 18-degree fluctuation in the temperature across all of the geometry, resulting in a 114-degree reduction in trapped heat within the core's geometry. That was over an 86% improvement in cooling. Another case study from Methods 3D showed how integrating conformal cooling can dramatically change or dramatically increase productivity. With the use of metal printing and conformal technology, they were able to achieve a 16% reduction in cycle time, which in return produced 600 more parts every 8 hours. Implementing direct metal printing with conformal cooling technology into our designs allows our customers to have a mold that achieves two things that normally don't come together when conventionally manufacturing a mold: increased productivity and also improved dimensional qualities of the molded part. Getting results like these allows the mold to do what it was designed to do: mold dimensionally good parts at a high rate of speed. Having a conformal line that follows and maintains a precise distance away from the molding geometry is the key to rapidly and uniformly cooling the mold's core cavity. The volume of the lines and its velocity of flow have to be of a sound design. A coolant passage that conforms to the geometry of a three-dimensional shape will naturally give you turbulent flow. Liquids typically travel in one of these three ways: laminar, transitional, or turbulent. Turbulent flow in a cooling line is when the fluid is no longer flowing even or steady in parallel layers. When the fluid is flowing smooth and steady, it is considered to have laminar flow. Transitional flow is when the fluid is changing from laminar to turbulent. To help better explain what turbulent flow is, I like to compare it to a raging rapid. As an example, when a river bends abruptly or obstructions disrupt the flow, it begins to transition into having turbulent flow. But keep in mind, the river is still supplying the same amount of water through this area. So then the water's velocity begins to increase, and a mixing and stirring action begin to happen. This is exactly what is happening inside of a 3D printed conformal cooling line. Along with the curvature of the 3D printed cooling passage and the rough surface finish also contribute to disrupting the flow, which in return makes it turbulent. In the molding world, turbulent flow is a wonderful thing. With the mixing action from turbulent flow, you rapidly begin to transfer heat away from the geometry it is traveling through, because you're mixing the warmer fluid that is near the walls of the cooling passage with the relatively cooler interior fluid. Being able to dissipate heat and maintain a uniform temperature throughout the entire molding surface is a mold designer's dream. We are using additive manufacturing not only for conformal cooling technology, but also for its capability of being able to build geometry that would normally be impossible using any other method. We are transforming solid, dense areas into honeycomb and lattice structures, making the parts lighter, but yet still maintaining or even improving the strength properties. Any geometry that we can transform into this type of organic shape helps drive down the cost, because fewer materials are required. We're routing fiber optic sensors internally through the geometry with the use of conformal technology, keeping costly sensors out of harm's way. B&J is now able to 3D complex geometry in the fraction of the time it would normally take to manufacture conventionally. The possibilities are endless with additive. This technology allows a designer to think and design totally different. No longer do you have to design based on what you can't do. You now truly have the freedom to think outside the box. With the use of additive manufacturing, for the first time, objects are being optimized for the function they will serve instead of the manufacturing process. I believe to become successful in additive, you have to learn a new way of thinking. You have to learn how to apply the DFAM, or the design for additive manufacturing concept. Allows you to design at a system level with the subtractive concept of manufacturing, where large blocks of steel were carved out and material is removed. Now, several assemblies are designed with subtractive, assemblies of several pieces are designed for its simplicity and its ease of manufacturing. Now, attacking the design at a system level allows the end product to potentially be a one-piece component or reduced to several key components. It is this radical way of thinking that can potentially simplify the complexity of the supply chain. This disruptive innovation of technology completely rewrites the book on how products can be manufactured within an organization. It's not just changing a single part for additive, but it is rethinking the entire design of the assembly. Standard design practices were all conceived in a world where additive manufacturing did not yet exist. We were all taught to design a certain way. We had to design for how a part would be manufactured. Optimizing a part's design for function couldn't always be accomplished due to the complexity. Applying system-level thinking in the engineering process has the power to change everything. Engineers with an open mind will become innovators overnight, and tooling companies willing to use additive in the production environment will become pioneers in what I feel is going to be the next industrial revolution. B&J Specialty is very excited to be at the forefront of using this technology in the molding industry. Having this technology at our fingertips opens up a whole new world of possibilities. This allows B&J Specialty, a U.S. company, to stay competitive in a world-class environment, and with the support of Methods 3D, what was once a vision is now a reality. Thank you.
Jarod, we do have time for a few questions if you're okay with taking some from the audience.
Yes, absolutely.
Are you seeing this being able to change the way that designs are done for injection molding? So like traditional designs, certain wall thicknesses, even wall thicknesses, are you taking it to that next level? Are you seeing that case?
At this point, not so much in the design change of the part itself. At this point, I'm seeing it being implemented in the construction of the tooling, with the utilizing conformal cooling technology, and also, being able to rethink how you design, based with this newfound technology of the subtractive ways of manufacturing, of the additive ways of manufacturing. But yeah, not so much in the actual plastic part yet, but I see it going there.
Got another one over here.
Good morning. Have you tested the conformal cooling versus conventional methods on the Reynolds scale or Reynolds factor, and if so, what are the results?
We have done several case studies comparing a side-by-side comparison of conventionally manufactured cooling passages with the use of like spiral baffles, the standardly manufactured cooling passages that we're all used to seeing in the molding world, with a true comparison side-by-side to conformal cooling. And it's all about the design of your conformal cooling. If you follow the guidelines, and the guidelines are, being able to maintain that critical distance away from the molding surface to the cooling line itself. If you're able to do that, and you're able to supply enough water into the component, and it's all done mathematically in a sound way, conformal cooling will give you premium results. It'll perform better than what any conventionally manufactured cooling line could produce. Now, it's not going to always be the solution. Where conformal cooling comes into play is reaching those vital areas of geometry that you don't have line of sight to be able to drill a hole. If you can conventionally manufacture and drill holes and use baffles and stuff like that, and it's working, by all means do that. But in those areas where you don't have direct line of sight because of the geometry, this is where the technology really shines.
Have you seen water quality adversely affect the effectiveness of conformal
Absolutely.
cooling?
Absolutely. That is one of the big key things that initially a lot of people don't think about. You tend to get blinders put on and you focus solely on that conformal passageway itself. But what is going to cause that to fail and fail rather quickly is the quality of water that you're supplying into it. So what I suggest and what a lot of molders are finding out is that you might be more beneficial to invest in a unit that is a closed loop system if that is something that you don't already presently have. Typically in a lot of the molding facilities, it's 30, 40-year-old water system that has been there since they got the building. It's cooling towers outside. They're black pipe running to all the presses. They use additives to try to reduce rust and everything else, but it's not going to be good enough for conformal, because with conformal, it's not like a standard baffle hole. If it starts to rust up a little bit, you remove the baffle and you drill it out. With conformal, you can't do that. So you really have to be aware of the quality of the water that you're running.
So obviously these designs are much different than your standard mold designs. How do you actually create those designs? Are you just using CAD, or is there a special?
Yeah, we at B&J are using Cimatron's package of mold design, along with they have it's specifically for 3D printing. It has tools aiding me in the construction of conformal cooling technology in the shape. But as far as the concept of what that line should look like, this is where it is new to everybody. Everybody has their own opinion on what they feel works. But with the utilizing the software for its analytical results, that is what is key at this point, because there's not just one set factor that works for everything. All geometry is different, so you really have to utilize your software from an analytical standpoint.
Are you seeing are you printing the internal passages with a different surface texture to affect the heat transfer? Are you doing anything along those lines?
The standard finish that you would typically get from the DMLS technology actually aids you in that turbulent flow that I was talking about. If you were to do, like some of the other machines that are out there, they do, machining while it's printing, so you essentially could have a very high finish on that inside, but at the same time with cooling, that you actually start to degrade your cooling properties, because now it's not being restricted, giving you that turbulent flow and dissipating the heat. So the rough finish does actually help you with cooling.
Is there a significant cost increase for the conformal cooling compared to the conventional?
There is, and that is where you have to design for additive. If you take a standard design that you're typically already manufacturing and you don't change anything to it, that is where the cost could be more. If all you're doing is just adding that conformal line to it and you're not reducing weight anywhere else, utilizing the technology to its full potential, then it potentially could cost you more than manufacturing conventionally.
Alrighty, that is all the time we have for questions. Thank you, Jarod.
All right, thank you very much.